This is what I'm effectively calling my pickleball collecting robot. And I've got these 72 millimeter, roughly 3-ish inches wiffle balls that I'm trying to build a robot that's able to pick up as many of these balls as effectively as possible. My question, what we're going to try to answer today, is just how far apart can we put these wheels before we're no longer able to effectively pick up a whole bunch of these little pickleballs? Now, this question particularly relevant in robotics because being able to pick up a spherical object is a really common thing. Be able to go pick up ping pong balls, tennis balls, whatever have you. Sometimes we call these robotic intakes. And I think that way too many people when they build these robots are using way too much surface area, and they really don't need to be using that much. So that's the presupposition that I'm going into this. Let's take a look at the experimental design to see how are we actually going to test how far apart are these wheels going to be. So as far as what the robot and testing setup is going to be, I have a little 45-degree angle ramp here with some grip tape on the front here so that as we push a ball in, it's able to lift itself up. I have set this up on some aluminum extrusion here. This is some Series 3 from Misumi that allows me to then move this bar up and down as I need to. It was just a quick way of me being able to figure out what is a good amount of compression for me to be able to push this ball up without actually lifting the robot up and off of the surface. I've got a pretty wide gate here for these balls to be able to pick themselves up in, and I just have a really solid bar here that's driven by 2 motors so that I can make sure that I'm still getting constant velocity even when I have really just insane amount of compliant wheels set up on this system. As well, in between each of these wheels, I'm going to be placing these 4mm plywood or multiplex spacers. And this is how we're going to be able to actually start testing the distance between these wheels. So between every single test, I'm going to add another spacer. I'm going to start taking some wheels out and I'm going to add another spacer in between, and we'll go up in about 0.4mm increments. So with these little spacers, what it's going to let us do is it's going to let us take out a compliant wheel, put in a spacer in between so that as time goes by, we will slowly increase the gap in between all of these compliant wheels. Let's talk a little bit about testing methodology. I've got 25 of these little 3 roughly inch wiffle balls. And then I have my large intake bar sitting over here. And the idea is we're going to take this robot, we're just going to drive it straight forward at a consistent speed to be able to then take a look in slow motion and see what and how many of these balls we're able to pick up efficiently and how quickly we're able to pick those up as well. Although we have to actually get to the wall in order for them to actually get picked up or so on. Now, when you're testing something and to be able to figure out how much distance we want in this, we have to be able to isolate out as many external variables as possible. Now, one of the challenging things here is that these are a ball, and of course, balls are slightly random, so they are going to fly around. But we can try to isolate out as much as we can. So I've got a square frame on the outside here so that the robot stays inside of a relative channel. I have the same amount of distance between my ramp and my actual rollers every single test, and I'm measuring that on both my X and Y planes to make sure that is the same. I'm going to be running this motor or this robot on a consistent speed. I'm running these at about a 435 RPM on 30A diameter or durometer, wheels. And then I'm just doing a chain drive here with 2 5-to-1 gear ratio motors. And then importantly, I'm also running this flywheel system here on a velocity-based system as opposed to a power-based system. And the reason I do that is so I can make sure the velocity or the revolutions per minute of this spinning bar stays the exact same between every single test, as well as the drive speed stays the same between every single test. I'm also going to try my best to set these balls back up in such a way that they will stay in that same test every single time. So hopefully by isolating out these variables, for the most part, we should be able to get some pretty accurate data to be able to say how far apart can these wheels start to be before it starts to actually affect that test. So if I had to hazard a guess as to how far apart these compliant wheels can end up being before we're going to start losing effectiveness, I'd have to start thinking about the ball itself. So if I measure the diameter here, we're sitting at about 72 millimeters here. So if I had to hazard a guess, I would say that probably when we start getting around the 25 to 30 millimeter mark between these wheels here, we're probably going to start to fail at that point. And the reason I think that we're probably going to start failing at that point is this might be the point where we're no longer able to actually connect to both sides of the ball. And what's really important here on compliant wheel intakes is that you need 2 wheels to actually connect with the ball. Because if only one wheel is connecting with the ball, it's going to want to push it out of the way. Of course, if it's directly in the middle, it will be able to pick it up. But if it's contacting on the edge, you really need 2 of these wheels to be able to actually pick this in. So my guess is going to be about 25 to 30 millimeters. I'd like you to pause the video now. Make a comment down below. How many millimeters do you think you're going to be able to get between, or how many inches do you think you'll be able to get between these compliant wheels before we'll no longer be able to successfully pick these balls up in an effective manner? Now, I'm about to show you all the test footage I just ran. And before you look at this test footage, I want to see what it is you want to look for. The goal of a really good intake in a robot is the ability to take it and own it. So effectively, if you are to touch that game element or that ball that you're trying to intake into your robot, you should own it completely, and that it shouldn't get pushed forward in front of your robot at all. If it were to touch that wheel, it should automatically go inside your robot and not be pushed forward. So that's the part you should be looking for. Now, one thing you got to check in this test is that at the very edges of my robot, there are flat corners. It does not actually ramp in. So if you see things being pushed on the edges, that may not be a correct representation of things getting pushed forward. You probably want to look at the middle range of those pickleballs. Now, a little interruption on that test footage. At this point, what was going through my mind is I think that I have a poorly designed test, or at least I thought I had a poorly designed test because it just kept working. And honestly, I couldn't believe that we could get this wide and it was still working. So I decided to do a little bit more random testing because maybe having it in that center slot ended up having a bit of an issue. So let's take a look at it in sort of a random distribution. Now, at this point in the testing, I had to do another random distribution. I honestly couldn't believe that I was able to get up to this wide. But what's really interesting here is that this was what was going through my thought process before I went to that slow motion video to be able to examine it. Because when you look at it in real world footage and real time, I could not tell the difference between when we started to get this wide. But we can tell from that video footage as those pickleballs starting to get pushed forward instead of automatically getting taken into the robot that we are starting to fail in performance when it comes to large blocks. But when it comes to randomized performance, we actually don't start to lose so much of that performance. And let's take a look at some of those tests. So the final thoughts here. This is the 72 millimeter. And even we saw that there's quite a bit of gap between these two. And realistically, the failure point actually wasn't surprising to be able to pick it up at a certain point. The failure point was when we started to get on the ramp and we started to go up. We actually couldn't connect with the balls enough to be able to get, or couldn't connect with the compliant wheels enough to be able to get ourselves up and past that ramp. So this experiment honestly really surprised me. The fact that we could take 72 millimeters and still have a relatively effective compliant wheel intake. I mean, we were able to get to the point here where now it's no longer able to contact both these wheels to then be able to get it up. So in terms of real world recommendations, what can we take out of this? Well, first one I think is that way too many people are using way too many wheels. You really don't need that much coverage on an intake, particularly when you're moving around for these little pickleballs or these little wiffle balls. You really don't need that much coverage on these things. Because we saw even 72 millimeters was still able to pick it up. Even 60 millimeters was still able to pick this up. And this ball is 72. So we were almost, 80, 90% of the full diameter of this ball before we were able to start to get up. And the failure point was not when we were able to actually pick it up. The failure point was getting up to that ramp and the compliant wheels be able to have enough contact. So in terms of real world suggestions, honestly, as long as you still have the ability to connect between both compliant wheels here and your ball is not contacting your actual main axle here, you're probably going to be fine using the maximum amount of space that you need to still be able to connect both of these compliant wheels up at the top at the same time. I would say anything from 40 millimeters to 48 millimeters is probably what you're going to be looking for, because that was the point in the slow motion videos where we started to see that as the robot drove into the large pack of pickleballs, all of them were still able to get picked up into the robot, but they weren't being pushed ahead. I'm curious, your thoughts. Were you surprised by when it stopped becoming effective? What was your original guess, and how far off were you off those centimeters? I'm legitimately flabbergasted at just how well even 72 millimeters is working here. And yeah, let me know your thoughts on the experiment in comments down below. If you'd like to build this for yourself, I've got the CAD file for this rover sitting in the description down below. And as always, best of luck on your next robotics project.